In question 5, we have a diagram showing an optical fibre. In A, we're to show that the refractive index of the core is 1.47. Well, using Snell's law, where the refractive index in medium 1, air, is equal to 1, we can rearrange for refractive index 2, put the values in from the diagram, and we get this to be 1.469, which is 1.47 to 3 significant figures. In B, we're told the refracted ray meets the core cladding boundary at the critical angle. In part 1, we're to complete the diagram to show what would happen to the ray after it strikes the boundary at X. There are 2 marks for this question. The line will continue horizontally to the right along the cladding core boundary, but for the second mark there will be some light also reflected at the same angle as the angle of incidence. If we were beyond the critical angle, we would then get total internal reflection with all the light reflected. In part 2, we're asked to find the critical angle. Well, the critical angle, from the diagram, using the rule that the angles in a triangle add up to 180, comes out at 80.46 degrees. In part 3, we're to find the refractive index of the cladding. Well, we can use the sign of the critical angle as n2 over n1, and rearranging for n2, we can then put in the values, and we get 1.45. In C, we're to give 2 reasons why optical fibres for communications have a cladding. Well, the cladding prevents signals passing from one fibre to another. It also increases the critical angle. This can reduce multipath dispersion.